Hello friends, in this video we are going to discuss about types of analog modulation techniques. Okay, what are the different types of analog modulation techniques and what are the definitions for the techniques in this video we are going to discuss. Okay, first let's see what is modulation. Modulation is the process of changing the characteristics of carrier wave in according to the characteristics of message signal. Now, in analog modulation, modulation is mainly classified into two types. First one is amplitude modulation and second one is angle modulation. Okay, in analog communication, the modulation technique is mainly classified into two types. First one is amplitude modulation and second one is angle modulation. And coming to amplitude modulation, this amplitude modulation is again classified into four types. Okay, this amplitude modulation is again classified into four types. First one is DSB-FC. DSB-FC is nothing but double sideband full carrier amplitude modulation. This is also known as standard amplitude modulation. And second one is DSB-SC. DSB-SC is nothing but double sideband suppressed carrier amplitude modulation. And third one is SSB-SC. Here observe SSB-SC. That is nothing but single sideband suppressed carrier amplitude modulation. And the last one is VSB. That is vestigial sideband amplitude modulation. These are the four different types of amplitude modulation techniques. Now coming to second classification of modulation, that is angle modulation. Here angle modulation is further classified into two types. First one is frequency modulation, second one is phase modulation. Okay, angle modulation is further classified into two types. First one is frequency modulation, second one is phase modulation. Here observe, frequency modulation is again classified into two types. First one is NBFM and second one is WBFM. NBFM is nothing but narrow band frequency modulation and WBFM is nothing but wide band frequency modulation. Okay, frequency modulation is again classified into two types. First one is narrow band frequency modulation and second one is wide band frequency modulation. Okay, first one is narrow band frequency modulation, second one is wide band frequency modulation. And coming to next classification, that is phase modulation. Here also phase modulation also classified into two types. First one is NBPM and second one is WBPM. NBPM indicates narrow band phase modulation and WBPM indicates wide band phase modulation. These are the two classification of phase modulation techniques. Now let's see what are the definitions for the amplitude modulation, frequency modulation and phase modulation. Let's see definitions. First, here see definition for amplitude modulation. Amplitude modulation. The amplitude of the carrier signal is varied in accordance with the instantaneous amplitude of the message signal. I already told you amplitude modulation is nothing but the amplitude of the carrier signal is varied in accordance with the instantaneous amplitude of the message signal. That means if the message signal amplitude is increasing, then the carrier signal amplitude also increasing. If the message signal amplitude is decreasing, then the carrier signal amplitude is also decreasing. That means the amplitude of the carrier signal is changing in according to the amplitude of the message signal. This type of modulation is known as amplitude modulation. Next, let's see what is frequency modulation. Frequency modulation is nothing but the frequency of the carrier signal is varied in accordance with the instantaneous amplitude of the message signal. Okay, here also the same thing. Here instead of amplitude, frequency of the carrier changes in according with the amplitude of the message signal. If the here amplitude of the message signal, here the frequency of the carrier signal. If the amplitude of the message signal is increases, then the frequency of the carrier signal also increases. If the amplitude of the message signal decreases, then the frequency of the carrier signal also decreases. That means here frequency of the carrier signal is varied in accordance with the frequency amplitude of the message signal. Next, let's see phase modulation. Phase modulation. The phase of the carrier signal is varied in accordance with the instantaneous amplitude of the message signal. If the phase is varied in accordance with the instantaneous amplitude of the message signal, then that is known as phase modulation. These are the three types of modulation technique. Next, let's see what are the waveforms for this modulation techniques. Let here observe, this is the carrier signal. First one is carrier signal. This is carrier. This is carrier signal. Okay. Next one is, let's see here. This is the carrier signal. This is carrier signal. And the second one is B signal is message signal. Message signal. This is AM modulated signal. This is FM modulated signal. Here observe, the carrier signal is having the high frequency and constant amplitude, constant phase. Here we have message signal next to it. This is the message signal. It is having the low frequency. Here observe, this is amplitude modulated signal. Here observe, whenever the amplitude of the message signal is increasing, here the amplitude is in positive peak. That's why the carrier or modulated signal amplitude is also increasing. Here observe, here the amplitude of the message signal is in negative peak. That means here the amplitude is decreased. That in according to that, here also the amplitude of the modulated signal is decreases. Here again starts to increasing. That's why here also modulating signal starts increasing. Here observe, here the modulated signal amplitude is changes in accordance with the message signal amplitude. That's why this waveform is called amplitude modulated waveform. And coming to this waveform, here observe, whenever we have positive peak, here we have positive peak, here we have negative peak, again here we have positive peak, and here we have negative peak. Whenever we have positive peak, observe here, there we have maximum frequency, and whenever we have negative peak, there we have minimum frequency. Likewise here also, here maximum amplitude is there. That's why here we have maximum frequency. Here frequency of the carrier signal is changing in according to the amplitude of the message signal. These are the waveforms for amplitude modulation and frequency modulation. I hope you can understand. Thank you for watching this video.